Hello friends, welcome to my YouTube channel Learn in Videos. So in this video we are going to see the logic diagram for 4-bit adder. So first we'll see the truth table for 4-bit adder. So this is the truth table for 4-bit adder where A, B, C, D are my input terminals and sum is my output and carry is also my output. So now for 0, 0, 0, 0 input we are getting sum as 0 and carry as 0. So for 0, 0, 1, 1, we are getting sum as 1, carry as 0. For 0, 0, 1, 0, we are getting sum as 1, carry as 0. Likewise, if we continue, we can fill up this column of sum and carry. So for sum, it's straight away that it's A XOR B XOR C XOR D. So this value will be our sum. So for carry, so there is a 4 variable K map which is over here, 4 variable K map. So when we inserted the value of ones and we formed the group, so this turns out to be AB plus CD plus AD plus AC plus BD plus BC. So this is the minimum expression that we can obtain from the K map for carry. So let us realize this in multisim and let us check the results. First, we'll go for multisim. So in this, we'll click on TTL. Now in this, we need to have XOR gate. So go for 74 ALS. So in this, scroll down and click on 74 ALS 86M. So here you can see 2 input XOR gate. So this is 2 input XOR gate. So I'll click on OK. So I'll click on A. So I want 3 XOR gates. So I'll take 3 XOR gates and I'll place it in this manner. So now I need to add input. So I want 4 inputs. So I'll take 4 function generators and keep at the top. If you want, you can copy this also. I'm copying and pasting it. So now we'll take the third input, paste it in the line. Now we'll take the fourth input. Now we shall configure this. So we need a square wave, frequency of 100 Hertz. Frequency is of your choice, but do not take too large or too large frequencies or too small frequencies. So third one, I'll be taking 200. Fourth one, I'll be taking 250 Hertz frequency. Okay, a square wave. So next, I'll connect this. I'll connect positive to first end, negative positive of the second one to the XOR gate. Now XOR gate output, I'll connect to one input of the next XOR gate. Next, I'll take input C and I'll connect to here, second input of the XOR gate. Next, the output of the second one, I'll connect to the input of the third one. Next, D variable I'll take and I'll connect it to the second terminal of the XOR gate. So now the output of the third XOR gate is the sum of A, B, C, and D. Now I'll take one oscilloscope. I'll take 4-channel oscilloscope. I'll place it over here. And also I'll take 2-channel oscilloscope. And I'll place here. For 4-channel ABCD, I'll attach 4 inputs. I'll connect this A with A, input A. I'll connect B with input B. I'll connect C with input C. Next, I'll connect last input D with input D. It is this one. Okay. Now my circuit diagram is ready. Now I need to connect the output to this oscilloscope, that is two channel oscilloscope. I'll connect it like this. Now when we want ground, so I'll click on place component. I'll click on sources, then power source, then I'll take ground. Okay. I'll keep ground over here. Now I'll attach all this negative terminal to the ground. I have attached one. This I'll attach to here itself. This I'll attach to here itself because it is attached to ground. This I'll attach to here itself. Yes. So this negative of the oscilloscope, I'm attaching it to ground over here. Okay. So now let us run this and check whether we are getting the right output or not. So no errors means our output is running. So let us open this. Now I'll reverse the screen. Let us open this as well. So on the right hand side, we have this one is the input and this is the output. Let us scale down our input. So this is 5 volts per division. Let us make it 50 volt per division so that signal is very small. Let us go to B. Let us make it to 50 volts per division. Now let us go to channel C. This also will make 50 volts per division. Now we'll go to channel D. This also will make 50 volts per division. Yes. Now click on A and we'll position A at the top by moving Y axis. So this is A. So this is A. Now I'll click on B and I'll position B below A. So this should be enough. Yes. Now I'll position C below B. Okay, C position is perfect. Now I'll position D below C. Yes. So this is our output and this is our input. Okay. Now I'll stop the execution. So now we'll pull this and we'll check. So now in this case, so we are checking at 3.4446. Yes. So now check here for 3.446. A is 0, B is 0, C is 1, D is also 1. 0, 0, 1, 1. So let us check what is the output for 0, 0, 1, 1. 0, 0, 1, 1. Output is sum is 0. And in this, we can clearly see that sum is also 0 in this. You can see it, sum is 0. So now let us draw the logic diagram for carry. So what does carry has? AB plus CD. So let me copy this. Let's go to multisim. Okay. So this is my expression for carry. Now I'll go to TTL. Now I'll click over here. So I want AND gate. So let us check for yes. So this is our AND gate. So I'll click on OK. I'll click on this A. So I want AND gate for A dot B. So how many AND gates I want? I want 1, 2, 3, 4, 5, 6 AND gates I want. So 1, 2, 3, 4, 5 and 6. Okay, 6 AND gate I have connected. I'll close this. So now we know that it's AB. So this is A. So I'll click on this and I'll click on A. Okay, so we know that this is B. So click on this and connect to this B. Okay, now we have AB is done. So we want CD. So this I'll connect to C. So we know that this is C. Okay, so now I'll connect this to, so this should be connected to D. Okay, this is connected to D. Okay, so next I want AD. So now I'll connect this to here. This is terminal A and this is terminal D. I'll connect it here itself, AD. Next I want AC. I'll connect this to this terminal to A. I know that this is A. Next I want C. So I know that the first entry it is C. So I have connected this to C. Next I want BD. I'll take this and I'll go to connect to B. So this is B. So this is B. I'll connect to B. Next D. So I know that this is D. This is D. Likewise, I'll connect to B. I'll take this and I'll connect here itself because I know this is the B terminal. Next, I'll connect it to C terminal. I'll take this. I'll connect to C terminal. This is the C terminal. Okay. So now I need to connect this all to one XOR gate. Sorry, one OR gate. Okay. So now let us go to CMOS and let us find whether we have 3 input OR gate. So the code for it is 4075. So here you can see 3 triple input OR gates. So I'll click on OK. I'll click on A. I'll paste it here. Okay. I want 2. Let me take 2. Okay. When I'll keep this side, let me close this. Now I'll connect this terminal to the output of first AND gate. This terminal for the output of second AND gate. Okay. The third input I'll give it to third one. Okay. Now this one I'll give it to the first one, second OR gate. Now the input of the fourth AND gate I'll give it to the second one. So here there is a little bit of mess. So let me clear this. I'll connect this to, oh, hold a second. Let me pull out that. Let me drag this over here so that it will be a straight line. Yes, now I can connect this to a straight line. I'll connect. Yes. Now from here, I'll connect it to. So now we have only 2 inputs, that is this one and this one. So I don't want 3 input. So I want only 2 inputs. Let us go to TTL. Let us search for AND gate. Sorry, OR gate. Yes. So 2 input OR gate. I'll click on OK. I'll keep it over here. Now I'll connect this to this and this one to the output of the last. Yes. So now I have got expression for carry. So now I'll connect this to B terminal, and B terminal I want to connect it to ground. Since the ground is very far, I'll take one more ground. I'll click on component. I'll click on sources. Then I'll click on ground. Okay. I'll paste it over here. Then I click this negative terminal B and I'll connect to ground. So let us run this and let us find it out whether our code is perfect or not. The code is running. So let us click on this. Let us click on this. Okay. So here let us move our carry. Okay. So I am moving carry up. Okay. The above one is carry. So now I'll stop the execution. I'll move back. I'll move this also back. Now we'll check. So let us zoom this a bit. Yes. Let's make this 2 milliseconds. Okay. So now we are checking at 3.682 milliseconds. 3.682 milliseconds. 3. This should be fine. Okay, 3.682. So now just check 1 0 0 0 1 0 0 0. Carry should be 0. So here you can see carry is 0. Okay. So now I'll move a bit further. So now here carry is 0. Check 4.032 milliseconds. 4.032 milliseconds. Okay. So A is 1, B is 0, C is 0, D is 1. So this turns out to be carry as 1. Sorry, carry as 0, sum as 1. So here you can observe carry is 0, sum is 1. Okay. So likewise, you can check all the other conditions and just note it down. What are the values? Okay. So I hope you have understood the 4-bit adder by this tutorial. So if you have any doubt, any confusion, you can comment in the comment section. And if you have any questions, just comment in the comment section. I'll try to solve it. And if possible, please do subscribe to my channel. So let's meet in next learning videos. Bye guys. And thanks for watching.